Let's figure it out a different way. This, going back to acceleration, is the change in velocity over the change in time. Those are supposed to be triangles. I know my acceleration is -6, because that's what I had over there. What will my change in velocity be if I'm trying to figure out the time it takes to stop? Close. You did initial minus final. It's the last one minus the first one. I mean, where the stopping minus the initial. So not 20, but I think you said it, or somebody said it. Not -32. When I said final, we're talking about just the stopping point. Not -18. The stopping. How fast is it going when it stops?
0.
0. Okay, we're going from 20 to 0.
20.
Not negative. Yes, it's -20. You forgot the negative. -20 over time. So we're solving for time. So -20 divided by what gets us -6? If you had put down +20 here, and you stayed true to the math, you'd end up with a negative time, which should have been a red flag saying, wait, something's off here. Now some students, when they get a negative where they don't expect it, go, I'm just going to pretend it's not there. Sometimes that works, sometimes it doesn't. Best if you get a negative sign where you're not expecting it, to try to figure out what's going on, as opposed to just ignoring it. All right, so I've got, the negatives will cancel out, so I have 6 over 1 is equal to 20 over t. So what is t?
3.
Say it again.
3.3.
Okay. And the 3.3 repeats. If you round off, that's fine. So the time to stop, 3.33 repeating seconds. Wait, I'm fine with rounding off. Don't round it off to 3. You just say 3 seconds. That's not right because it's going 2 meters per second at that point. All right. Questions up to here before we talk about the distance to stop. All right, let's talk about the distance to stop. In the time from the beginning of the problem to when it stops, not when the problem stops, but when the object stops. So from here to here. What is the average velocity? In the first 3.3 repeating seconds, what is the average velocity? Squeeze this one.
10 meters per second.
Yep. From start to start of problem to object stop. All right, so 10 meters per second. Who said that? How'd you get 10 meters per second?
Do you take the average of 20 and 0?
Yep. It's the average of this 20 and 0. So what is the distance it travels from the beginning of the problem to when it stops? Or how would you find it? on average, you're going 10 meters per second for 3.333333 seconds. How far did you travel? Or how did you find it?
What was the average?
This is 10 meters per second from the beginning of the problem to when it stops partway through it.
100?
Be what?
100?
Not 200.
300.3.
Say it again.
We're multiplying average, V average, time to stop.
Yep. And so the distance it takes, it's stopping is just average times how long it was doing that average. So that's 33.3 meters. So let's try to get a picture of what's going on here. I know that it turns around. I know it turns around because the velocity is positive here and negative here. And I've also could have started negative and ended up positive if I flip the acceleration also. But it goes from one sign to the opposite sign. It stops in between to turn around. When it stopped, the acceleration was not zero. The acceleration was still -6 meters per second squared. So it starts at some location traveling in the positive direction, and I'll just say to the right's positive because I'm a creature of habit. It's going to go to the right until it has gone 33.3 meters. And that's the point where it stops, turns around, and goes back. I know, because we've already figured it out, how far it ends up from where it began at the end of the problem. That it ends up 192 meters from where it began. So that's 192 meters. That's 33 1/3 meters. So what was the total distance it traveled? Say it again.
228.
No.
225. 225.
It's not 220 or anything.
Is it 250?
Yeah. Why?
Because you gotta add the 192 plus the 33 to get the whole trip from one side to the other, and then add the 33 that she turned around.
Yeah. It takes 33 meters out to here. It's 33 meters back to the starting point. Then the 192, you end up from where you started. That missing that, forgetting that bit right there, that's the most common mistake when people get this far. So it is going to be 33 out, 33 1/3 out, 33 1/3 back to the start point, and then 192 to finish it off. So that was 258.6 meters. And then the average speed Say it again. 21.5. There we go. I'm assuming 21.5, someone else got it? I think I saw some subtle nods.
How did he get that?
How'd you get that?
I divided 258.6.
It's distance divided by time. So it was the distance divided by the 12 seconds.
How did he get the 10? After the T-stop, how did he get the 10 meter seconds?
How'd you get that?
Yeah.
The question is from the start of the problem to when the object stops. Not the stop at the end of the problem, but when the object stops at this point right here.
The 3.3.
So that's 3.33 seconds to get to there. When it stops, it is going 0 meters per second. So there's a 0 in there at what we found out was 3.3 repeating seconds. If I'm trying to find my average velocity, I just average the first and the last number. So it's starting at 0. Average of 20 and 0 is 10. That's where that comes from. So for this, just this bit, the average velocity was 10 meters per second.
Okay.
So with the 21.5, would the 5 not be repeating?
That's possible. You got 5 repeating?
I got 21.5 last.
5.
And then it doesn't show.
On a quiz or test, if it's 21.5 repeating and I look down, I can see 21.5, I'm going, okay, I'm fine with that. On labs, that's when I get really picky about rounding, tests and quizzes. I will look at that and go, yeah, the person, there's a rounding in there somewhere, but it's not worth my time to figure out where the person rounded.
How did you get the number 6 again? The second to last one? Change in X?
That,
Yeah.
this is distance.
Okay.
So it's the total distance traveled. If you were in a car, it's what the odometer would read. You go out, so you start out in the positive direction, stop, turn around, and you end up somewhere in the negative side. I know you end up on the negative side because my displacement is negative, so I'm going to end up on the negative side of where I started. So an analogy is I take 2 steps this way. Okay, that was 3 steps. So I'll take 3 steps this way, 3 steps to get back to the start, and then I take 4 more steps. I end up, if that's the positive direction, I end up with a displacement of -4 meters, because this is where I am relative to where -4 steps, because this is where I am relative to where I started. So my displacement will be -4 steps. But the total distance traveled is 3 plus 3 plus 4. I took 10 steps. And so we did the same thing here. We ended up, this is our starting point, we ended up 192 meters on the negative side. We figured that we went 33 1/3 meters to get to the stopping point. So 33 1/3 plus 33 1/3 to get back to my starting point, and then an additional 192. There are what I believe to be more complicated ways of coming up with the same answer. You could have also have, similar to the technique of how we got this 33 1/3, you could have done I'm starting at 0 here, 0 meters per second. I end up at -52 meters per second. Find the average, which would be -26 meters per second. And that would be for whatever 12 minus 3 1/3 is. And multiply that with that, and that would give you that total distance backwards. Actually, the negative would give you the displacement backwards, but it's in one direction. Absolute value is the distance. And again, I can just feel the excitement and energy and thinking, oh, I hope we do a lab with this stuff. Sort of. The lab's more related to what we did on Tuesday. Questions? Michelle?
I know you just explained it. Can you explain one more time the distance to stopping, the 33.3 meters?
This one?
Yeah, can you explain that?
All right. If I change the problem and I just said, you're going 20 meters per second and you're slowing down at -6 meters per second until you stop, how far did you travel? That, in essence, is this problem right here. Starting out at 20 meters per second, ending when you stop, how far do you go? Well, similar to what we did up here, your average velocity, well, I'm going from 20 to 0, so my average is 10. And The time to stop, well, that requires a little bit more sophisticated math. Acceleration is the change in velocity over time. I'm going from 20 to 0, so that's negative 20. Over my time is equal to negative 6, which was given in the problem. And so you solve for t. That's where we got the 3.33 seconds. We found that average, but again, by averaging the 20 and 0, you multiply it to get that. So that's how far we went in the positive direction, we stopped, and then we turned around. Did that answer your question? Okay. Other questions? Yes,
I thought
Elizabeth.
the negative 6 would be in place of the t.
The negative 6 is acceleration. If I'm plugging into this formula right here, it is in place of a. I'm trying to find time. Now, mathematically, if I've got 20 over t equals 6, I can stick anything over 1. If I have two fractions equal to each other, I can move stuff along the diagonal without any loss of math. So if I just flip those around, t would end up being 20 over 6. So officially, when I'm plugging into this formula, acceleration is negative 6, not time. But when you actually solve it mathematically, t is just the 20 divided by the 6. I hope I made that clearer.
Yeah.
Okay. I assume that yes was, yes, you did. Other questions? All right, I know that I got an email from at least one of you on the master set 3. Hopefully that'll be clearer now. I'll just do that one. I will tell you that on the test, I will have an object that will change directions. The distance will not be the absolute value of the displacement. So something like this. So this is very similar to a test problem. I'll change numbers around. Maybe I'll start it in the negative direction and have it turn around and then go in the positive direction. But this is very similar to a test problem and a master set problem. In supplemental materials, I think it's labeled like Fox-made materials, something like that. I have additional materials from chapter 3, and in there I've got 6 worked out problems where I solve it slightly differently in different problems. I think in 3 of them, I give this type of information, and in another 3, I give you like that information, and I don't give you time. Or maybe I give you time and I don't give you acceleration. I forget what it was. But there's some variety of problems under the supplemental materials. I think that's where I started. All right. And on that note, we're going to head down to the lab room. I'm going to go grab the labs. And we will, of course, rejoice.
When is the test?
When? I don't know yet.